Welcome back to Calculus. We're going to do a bigger problem from 3-6 now. This one, number 16. And I will not get this done in one video. I think YouTube doesn't like me to go over 15 minutes. And this one's probably going to take 22, 23, 24, I don't know, 25 minutes. So I'm going to break it into two videos. I'll start and see how far. I'll probably get through the first derivative analysis and then have to break it up to a part 2. So this is number 16, 3.6. If you can read that, that's a 16. And it says f of x equals x cubed over x squared minus 4. Let's factor. Let me put that below, actually. Working vertically. And we get x cubed over x minus 2, x plus 2. So no surprise that there is domain is going to be all reals, except our exclusions, x equaling 2 and negative 2. And really the importance of that is those are vertical asymptotes. I'm changing color. I can't write with purple for some reason. There we go. Vertical asymptotes are x equals 2 and x equals negative 2. That's going to be important. Horizontal asymptotes, the numerator is greater here, so it's none. You feel happy when you write none, but you probably shouldn't, because what does that mean? That means there's a slant asymptote. And what does that mean? That means we have to do division. We get to do division. You could do synthetic or long. If I were to do long, I would do x squared plus 0x minus 4, which is this, but with a 0x placeholder. And I'd put x cubed plus 0x squared plus 0x plus 0 here. But you know, you could do synthetic. Is it worth it? Now let's just do this. So I'm going to count over 1, 2, 3 of these. So I go 1, 2, 3 over here, and I start in the x column. What times x squared equals x cubed? Well, it is x. So x times x squared is x cubed. X times 0x is 0x squared. X times negative 4 is minus 4x. Now, if you've been in my class before, you know that I like to change the signs of all these and add them, just because I add better than I subtract. And by putting them in the parentheses, it reminds me that, no, these were not the original signs. I changed them so that I could add. This becomes 0 x cubed, this becomes 0x squared, and this becomes just 4x. And you can drop down 1 of 0. But we're not going to get anything else. There's nothing that can go here. So our answer, another way to write this function is x plus 4x over x squared minus 4. And in that in mind, it's clear that as x goes to infinity, as it gets massively large, this term will go to 0. And the function approaches just x. So our slant asymptote turns out to be y equals y. Slant asymptote is just y equals x. Because of this right here, it's y equals that thing. This goes to 0 as x gets massively large. Okay, so that's key. That's probably worth noting. That's key. What else when you do intercepts? Well, remember, if you set the numerator equals 0, well, then x is 0. That is your x-intercept. Just label it like that. I like to write as a coordinate because there's no doubt how you graph coordinates. So let's do that, and that is key. Also, we'll put that on the graph. And if 0, 0 is an x-intercept, it's a y-intercept. If you plug 0 in here, you plug it in here, you plug it in here, you're going to get 0 over -4, which is 0. So this happens to be our x-intercept and y-intercept both. Okay, so the pre-calc analysis is complete. Let me check my work. Looks good. On to the first derivative. Okay, first derivative of, let's write it out without factoring, because we don't want that. We don't want to do that. Have to deal with product rule. X squared minus 4. So we take the derivative. First thing you do is write the denominator times the derivative of the numerator. Don't forget parentheses, please. Minus the numerator times the derivative of the denominator. All over the denominator squared. What can I factor out? Please factor. It helps. It makes it a lot easier. I see that I could factor out x squared. Is that all I do? I think so. Factor out x squared in the numerator. And I can't pull. There's no way you're pulling this. It's in a term with -4. We can pull that out. That's gone. And part of this is gone. So we're left with x squared minus 4, and that times 3, minus this 2x times the remaining x that wasn't drawn out. Now I think you're not going to be surprised what's going to happen here. We have 3x squared minus 12 in the parentheses minus 2x squared. What do you know? We have like terms left over. This, by the way, was a really poor equal sign. Let me erase that. Equals all over x squared minus 4 quantity squared. Nothing cancels there. This is a double check. So we end up with x squared times x squared minus 12 all over x squared minus 4 squared. And if you set that equal to 0, you will note that, whoa, what happened there? Hang on, hey, erase. Too powerful for my eraser. It's not good. Okay, forget that. So x equaling 0 is a 0. Also plus or minus the square root of 12, which happens to be plus or minus 2 square root of 3. And then what makes a denominator equal 0? We've already said this, 2 and negative 2. So those are things that we need to check. These are considered critical numbers. The top 3 or the zeros, the bottom 2 or the place it does not exist. So look at this long list we're going to generate. I'm going to go to another color. We're going to have to look something around -2 squared root of 3. By the way, that's about 5 or something like that. Also should check -2, 0, 2, and then the other 2 square root of 3 that's positive. I did not give equal spacing here. Now 2 square root of 3, let's see, square root of 3 is about 1.7, so 2 square root of 3, okay, it's about 3.5. So I can get by checking 4 over here. Let's see. So if I try -4, and then it says about 3.5, -3, -1, 1, 3, just looking at symmetry here, and 4. Okay, I think we were just doing, I had to get up and do something. we were doing the testing these intervals. So let's look at what we have. We have a square that's also always positive. Change colors here. Square is always positive. This square is always positive because notice x squared minus 4 won't be positive, but the square there will make it positive. So this is going to make all the difference right here. If the squared number is bigger than 12, it'll be positive. If it's less than 12, it'll be negative. That means really we're only looking at the absolute value of the number we're squaring. So you square 4, you get a number bigger than 16, so that's positive. You square 4, you get a number bigger than 16, it's positive. But if you square 3 or negative 3, you subtract 12, you can get negative. If you square 1 or negative 1, you subtract 12, it's going to be negative. So that those four are all going to be negatives. So we are going to have a increasing function, just the beginning and the end, from negative infinity to negative 2 square root of 3 in union with 2 square root of 3 to infinity. And then it's going to be decreasing. How do I write this? Let's see. Decreasing from negative 2 square root of 3 to negative 2 in union with negative 2 to 0 in union with 0 to 2 and one more in union with 2 square to the 2 square root of 3. 4 regions, they're all back to back. If you said, sorry the yellow's hard to read, if you did this, I don't think I would necessarily count off. If you instead just said from negative 2 square root of 3 to 2 square root of 3, but I think it could be a little confusing because at negative 2 and 0 and 2, this function does not exist, at least at 2 and negative 2. And at 0, the slope is 0, but it does not change signs. So, you know, I think the yellow is better, though, personally. Okay, lastly, we need to talk about relative minimums and maximums, and we will have 2 of those because there's 2 places where it changes. So one changes here, and one change happens here. The first one goes from positive to negative. That's a relative maximum. That occurs at 2 square root of 3. If I plug that in my output, you can trust me on this, is going to be negative. You know what? That should have been negative 2 square root of 3. Negative. It's going to be negative 3 square root of 3. And like I say, you can check that for me if you want. Your relative maximum is going to be at the other end at positive 2 square root of 3. And nice symmetry here, the max, that is going to be 3 square root of 3. And no, that shouldn't be maximum. This should say minimum, shouldn't it? Sorry about that. That's a relative minimum. Okay, we have merely done our pre-calculus analysis and our first derivative analysis. I'm going to end this video, and we'll come back and do our second derivative analysis and graph. Thanks for watching.
Made with Doodlecast Pro.